Good afternoon. Hope we're all doing well. Like Brian said, my name is Lennart Bendfeldt. I'm the Solutions Manager at eFactor 3. So what we are is we are an engineering and machinery systems house. So we provide solutions in the waste to energy sector, in advanced or chemical recycling, as well as traditional mechanical recycling. That looks like everything from shredding, optical sortation, washing equipment, and extrusion equipment. My dad founded this company 17 years ago, and we've been working nationwide since then. So we've seen quite a few different applications in those times, and it's given us a lot of insight into how, as Brian was alluding to, advanced recycling differs from traditional mechanical recycling, and how you have to approach the preparation of that feedstock. And that leads us to the title of this presentation, Feedstock Preparation for Advanced Mechanical Recycling. This is me about 40 pounds ago. I think I need to get a new picture in there. But as I said, we've been supporting both mechanical advanced recycling operations for the last 17 years. And we tailor fit those solutions to our specific clients, right? It's not a one-size-fits-all solution. Depending on where you are located in the world or in North America, your trash is going to look different. Your plastic is going to look different. You can't build a washing system the same way you can in Asia as you can here in North America, right? So it requires an intimate knowledge of how those markets and how those materials and feedstocks look throughout the world. And we source our machinery from 9 different partners across Europe. As we know, in a lot of ways, European countries tend to be quite a bit ahead of us when it comes to the recycling game. So our partners are based in Germany, Austria, Italy, and Denmark. But let's talk about the important thing, which is feedstock. As much as I believe people like Mike when they say that their pyrolysis or gasification system can take any material, that's awesome. And like I said, I believe them. But the question is not, can your system handle this material in general? The question is, can it handle it economically, right? If you have a higher percentage of contamination, you're going to have higher levels of black carbon, higher levels of buildup in your system. You're going to have more problems disposing of that as well. And in addition to that, you also are transporting more garbage that is not leading to a better yield before you even get into your system. So that's kind of what we focus on at eFactor 3. Incoming streams of trash, what are they? They're mixed, they're inconsistent, contaminated with all kinds of metals, films. Sometimes those are desirable, sometimes they're not, and organics. As we know, there's advanced recycling and then mechanical recycling. Mechanical recycling, as Brian was alluding to, requires high purity plastics. Sometimes we need to get into hot washing plastics even with soap, which is not a fun process. That takes a lot of energy, it takes a lot of commitment. Advanced recycling in a lot of ways gives us more flexibility to process those materials, as advanced recycling can handle higher levels of contamination. What does something like that really look like at the end of the day? How can we take a dirty stream of material and, again, although we may be able to process it, how do we make that process more efficient by increasing the purity of our materials? Of course, first, downsizing that material is an important step to get it into a workable form. And then different levels or types of sortation. You can sort based on material. You can sort based on size as well as density. So through types of machinery like wind sifting, like disc screens, or eddy currents and optical sorters, you can start to sort those materials and get a more pure stream for your gasification or pyrolysis system. I'm just going to go past this. So our primary shredders, where we're starting off at, these are generally the the beginning of any recycling process that we see in the modern world, right? These are high volume pieces of equipment, especially as we talk about advanced recycling. A lot of our clients come to us and say they want to do 30 tons an hour of material. Whether that's realistic or not, that's up to them. But, we need to be able to fit that specification. So one of our partners, M&J out of Denmark, and they produce these high volume, heavy duty shredders where we can break down the incoming material regardless of what kind of contamination we have. If you've got metals in your stream or pieces of glass, those will wear down your machines very quickly. And again, just because the system can take the contamination doesn't mean that the wear is not going to be so high that you're going to be replacing parts every 5 minutes anyways, right? And when you're doing that, does it really offset the fact that you can take any kind of material? And with pre-shredders, you also have stationary shredders as well as mobile shredders. As Brian was talking about with, these decentralized pieces of equipment, that's also important in the feedstock preparation. If you have to take, plastic films from a MRF 50 miles away to a secondary processing facility, run it through that process, and then ship it again to a pyrolysis system or ship it to a gasifier, that, again, just increases your cost. If you can move those pieces of equipment because they're mobile to a landfill or to a MRF, just like your decentralized piece of equipment, that already starts to cut down on a lot of that cost and make that process more flexible. As we spoke about density separation, so that would be with something like the Airstar from Wisteria that can separate materials based on their density. So that it runs across an air knife, and anything light is going to fly further, anything heavy is going to fall out at the beginning. And that allows us to get out some of the really bad stuff that really nobody is going to benefit from. Pieces of heavy metal, heavy rocks, right? Just because your system can handle it, doesn't mean that it's going to benefit your process in any way. And this is a pretty simple way of getting it out that is not highly technical or anything. It just simply works on the density of your material. This is a little bit of an illustration of what that looks like. Again, material comes in. We run it over an air knife. Any light materials are going to jump over that separation drum, and heavy materials are going to fall down in front of it. You get a pretty clean separation. It's something used very often in Europe, for example, in RDF production. You get MSWN, and then you separate the lights, the heavies, and the mediums, and you can get a very clean film fraction just in one step using something like a wind sifter. This is another one of our partners, EcoStar, based out of Italy. So they have a patented disc screening system called the Hextra or Hexac, depending on the material, depending on the model. Come in both stationary as well as mobile. And they're very well oriented to separating the organics from things like films, used very often in anaerobic digesters. And then when we talk about metals, again, that's a very common piece of contamination. Just because you can handle it doesn't mean it's ideal. Also, a lot of these things like used beverage containers, pieces of aluminum, they can be quite valuable on their own. It can make sense to install, eddy current or a magnet or something like that to get that out ahead of time and even sell that as a separate commodity. And then, of course, comes the secondary size reduction. These are higher RPM, lower throughput shredders that can get materials down to an inch or two. They're more sensitive to things like metals, which is why we want to get everything out before that. But they create a homogeneous type of material that can then go into your pyrolysis system, into your gasification system, and create that homogeneous material. Again, just because you could take in, large varying pieces of material doesn't mean that making them more homogeneous at the end of the day would not provide you with a more efficient process at the end of the day. This goes a little bit into the mechanical recycling side of it, but one challenge that you have when you have some of these materials is the contamination causes pretty horrible odors. I think most of us in here have been in MRFs, in waste facilities. We like to joke about things like, oh, it smells like money, but it doesn't smell nice, does it? So you can use things like infrared decontamination to actually not just clean the material and make it safe for food contact. You can also use it to release the volatiles from that material and make a better smelling material that can then be sold on for injection molding or blow molding applications. And when talking about mechanical versus chemical recycling, another big topic is washing versus not washing. How does your end product look and what kind of goals do you have? That's why I mentioned at the beginning how important it is to define your incoming stream and how it needs to look at the end. If you have a more sensitive process, you may need to look into washing, whether that washing is a dry wash, a wet wash, or a wash that even includes soap in it. That is a critical question that we need to answer well ahead of time. And this is just some of the different market segments that we work in and that can be applicable to all sorts of pyrolysis and gasification processes, whether that's the wood waste that comes from C&D, agricultural plastics, as we'll be talking about later this week at the Ag Plastics Conference, or MSW residuals. And here's an example of just a simple processing line, going from something like, oh, there we go. Shredder to a magnet over here to pull out any of the large pieces of metal, going into a screen to then sort that material by size, and then sorting based on density here with the wind sifter. Once we've got that done, we can then do the final size reduction and create that more homogeneous RDF, or whatever fuel that you're looking for, feedstock for your pyrolysis or gasification. In the next couple slides, I'm just going to show you a couple of examples of, little flow charts that kind of outline how you could get to your desired results depending on what the process looks like, right? In the film recycling world, again, we were going from primary shredding, magnet, screening, wind sifting, and secondary shredding. So that's what you just saw on the last slide. And then depending on that end process, we can then go into different pieces of equipment. So if we really want to get a top quality mechanical recycling material, something that goes into blow molding, for example, we may have to go through a wet washing process. If we're going to chemical or advanced recycling, sometimes the dry cleaning or even no cleaning is required, just depending on how that in-feed looks. And these are some of the partners that I discussed here. If you guys have any interest in talking to us about different pieces of equipment that we provide, different services that we provide, then come find me after this discussion. Yeah, that's pretty much it.